Hi students, welcome to the second part of this video. Now we will discuss about the double displacement reaction. In a double displacement reaction, there is mutual exchange of the radicals between the different compounds. So suppose we have a silver nitrate solution, and if I react it with the sodium chloride solution here, NaCl, the two compounds actually they exchange their ions. Silver reacts with the chlorine and forms the silver chloride. A white precipitation of silver chloride is formed once we react the sodium chloride solution with the silver nitrate, and the sodium now reacts with the nitrate and forms sodium nitrate, NaNO3. So here in this reaction, two compounds exchange their radicals, right? So silver reacts with the chlorine and sodium reacts with the NO3. So this is a double displacement reaction. Let's see the reaction here. I have prepared a video of the same reaction where I am going to react silver nitrate with the sodium chloride. Here we have two compounds, sodium chloride and silver nitrate. I'll prepare a sodium chloride solution first, dissolving the NaCl in the water. So I got NaCl solution here, sodium chloride solution, shake it. Okay, now we got the sodium chloride solution, aqueous sodium chloride solution. And now to this sodium chloride solution I am going to add silver nitrate, AgNO3. So you will see, once I add the silver nitrate solution, AgNO3 solution to this, immediately a white precipitation will be formed. As soon as the compounds combine, you see the white precipitation quickly. So this is what? This is a precipitation of silver chloride. So that means if you mix the two elements here, if you mix the two compounds here, silver chloride, silver nitrate and sodium chloride, you get a silver chloride and the sodium nitrate. So here this is a double displacement reaction because the two compounds exchange the radicals. Silver reacts with chlorine, sodium reacts with nitrate. This is also called as a double decomposition reaction. Double decomposition reaction. Okay, so double displacement, you can also call it a double decomposition reaction. Now these are some other examples of the double displacement reactions. Here in these examples, here in these compounds, silver bromide and the silver potassium bromide. Here in these examples, potassium bromide and the silver nitrates, you can see here potassium reacts with the nitrate, forms potassium nitrate, and the silver reacts with the bromide, forms the silver bromide. So again this is a double displacement reaction. Another one, NaCl and the sulfuric acid. So you get the sodium sulfate and HCl, right? Another one, sodium sulfate solution and barium chloride. So once you mix the two compounds here, you get a barium sulfate solution. Precipitation of the barium sulfate will be formed and you get the NaCl. So here in all these examples, two compounds exchange the radicals, right, and form the different compounds here. Now another one of the important reactions, that is a redox reaction. Okay, redox reaction. In a redox reaction, one substance gets oxidized, another substance gets reduced. So redox reaction is a reaction in which oxidation and reduction takes place. A reaction in which oxidation and reduction can take place is called as a redox reaction. But what is oxidation and what is reduction? Okay, so there are two concepts. The classical concept is in terms of adding the hydrogen and the oxygen, right? So oxidation is simply addition of oxygen or addition of electronegative element, right? Addition of oxygen or addition of electronegative element. And reduction is addition of hydrogen or addition of any electropositive element. Okay, here is an example. In this example, oxygen adds to the magnesium, so we see the magnesium is getting oxidized here, right? Magnesium is oxidized here. But what about the oxygen? Oxygen getting reduced. Why? Because magnesium adds to the oxygen, right? So addition of a magnesium, which is electropositive element. Magnesium is an electropositive element. So addition of magnesium to oxygen is reduction to the oxygen. So we can say oxygen is getting reduced and the magnesium is getting oxidized. So therefore this is a redox reaction. Okay, so addition of oxygen is oxidation, or addition of electronegative element is also oxidation. Let's take another example. Here you see hydrogen adds to the chlorine, so we can say chlorine is being reduced, because reduction is what? It is the addition of hydrogen. So when hydrogen adds, that is reduction. Addition of hydrogen or addition of any electropositive element, right? And what about the hydrogen? Hydrogen, it gets chlorine, right? Okay, chlorine is added, chlorine, which is electronegative element, adds to the hydrogen. Therefore hydrogen is oxidized. Okay, so I can summarize here the oxidation and reduction here, right? What is the oxidation? Okay, so I'm going to make a small table here for the oxidation and reduction. What is oxidation? Oxidation is addition of oxygen, right? So I'll use the plus sign for the addition, means plus sign for addition. So therefore addition of oxygen or any electronegative element, is oxidation, right? And what is reduction? Reduction is addition of hydrogen or any electropositive element, right? Addition of any electropositive element. Oxidation is also the loss of hydrogen. Okay, if we remove the hydrogen, that is also the oxidation. So you can see here the second definition, removal of hydrogen. So when hydrogen is being removed from any substance, so we say this is oxidation. So for the negative sign, I am going to use for the reduction, for the removal, I am going to use the negative sign. So here it means loss of what? Loss of hydrogen, okay, or removal of hydrogen, or removal of any electropositive element. Electropositive element is oxidation, right? So addition of oxygen or loss of hydrogen, that is oxidation. Reduction is addition of hydrogen or the loss of oxygen. So minus means loss of oxygen or loss of any electronegative element, right? That is reduction. So addition of oxygen is oxidation, loss of hydrogen is oxidation, addition of hydrogen is reduction, loss of oxygen is again reduction. So here is an example, right? One of the example. Here is a video for one of the redox reactions. In this video we can see here, I'll react the magnesium with the oxygen. So let's see what happens there. Once I take the magnesium and when I give it a proper ignition temperature to it, it starts burning. It reacts with the atmospheric oxygen, right? The magnesium reacts with the atmospheric oxygen and forms the magnesium oxide. So therefore we can say the magnesium is getting oxidized, right? Why? Because magnesium is oxidized because there is addition of oxygen on the magnesium, okay, and oxygen is getting reduced because magnesium adds to the oxygen. Magnesium is electropositive element. Addition of hydrogen or addition of any electropositive element, that is reduction, right? Okay. Here is one more example of a redox reaction. In this reaction, the zinc oxide reacts with the carbon and forms the zinc and the carbon monoxide. So what we find here, oxygen is being lost from the zinc oxide, and zinc over here, what we find, there is loss of oxygen. So loss of or removal of oxygen is what? That is reduction. Okay, so we can say zinc is getting reduced here, and carbon converts into the carbon monoxide. So carbon adds to the oxygen, so oxygen adds to the carbon, so we can say carbon is being oxidized. Carbon gets oxidation, right? Another example, sulfur and oxygen. Addition of oxygen to the sulfur, it is oxidation, and you can say addition of sulfur to the oxygen, that is reduction. So we say here the the sulfur here is getting oxidized and oxygen is getting reduced. Okay, oxidation here, and the oxygen is being reduced here. This one is a classical concept of the oxidation and reduction. Now a more modern concept of oxidation and reduction is called as electronic concept. So we can explain oxidation and reduction, we can explain the redox reaction in terms of the loss and the gain of electrons. The loss of electron, that is called as oxidation, and the gain of electron is called as reduction. So if you look at this reaction here, the zinc, if you react to the zinc with a copper sulfate solution, you take the zinc metal, zinc rod, react with the zinc copper sulfate solution, we get a zinc sulfate and the precipitation of a copper. So over here in this reaction, the zinc displaces the copper and forms a zinc sulfate, and copper is precipitated out. So this is also a displacement reaction, but this is also a redox reaction. Why? Because in this reaction we find loss of electron and the gain of electron. So what happens here? Actually, suppose if you have a copper sulfate solution, CuSO4 solution, copper 2 plus sign, sulfate 2 negative ion, and once I insert the zinc rod in it, okay, the zinc rod in it, what we find just after some time, 1 or 2 minutes, you get a precipitation of a copper. So a PPT of a copper is being formed, and the weight of the zinc rod decreases. Okay, so from the solution, zinc displaces the copper, and that copper precipitates out. Okay, so here the actual reaction is, first the zinc rod, the zinc metal, it changes into the zinc ions and electrons, and these electrons then they're taken by the copper. So the copper ion accepts the electrons and forms the copper, metallic copper here. So zinc, it loses electrons, so this is oxidation, and copper, it gains electrons, so this is reduction. So therefore this is a redox reaction in which zinc is being oxidized and copper is being reduced. Zinc undergoes oxidation here and the copper undergoes reduction. So therefore this is a redox reaction. In a redox reaction there is loss and gain of electron. This is a more modern concept of a redox reaction. So loss of electron is oxidation and gain of electron is reduction. Hope you got this concept. Thanks for watching the video. Bye for now.